Okay, this video is going to go through the transformations and similarity review. So this just is going to help you hopefully set up each problem. It won't give you the answer, but it will help you set up each problem individually, okay? So our first 10 questions are all about similarity. So we've got a building is 60 meters high and casts a shadow of 12 meters. So how tall would a baby koala be if it casts a shadow of 2 centimeters? So we've got, here's the building. I'm going to draw a picture. I know it is 60 meters high and casts a shadow of 12 meters. Okay. And then the baby koala, I don't know how tall it is, but I do know its shadow is only 2 centimeters. So baby koala is pretty small then, I guess. I'm assuming that they make a little right angle here, and then this would be kind of like a triangle. And assuming that this is all at the same time, then those triangles would be similar because the shadows should be the same proportion, right? So we could say that 60 belongs with the thing I don't know, just like 12 belongs with 2. There's so many different ways you could have set this up. You could have done 60 over 2 is something over, 60 over 12 is something over 2. You could have done so many different proportions here. They will all get you the same answer. So after that, then you just cross multiply and solve the equation. I'm going to change the question mark to an X. When we cross multiply, you'll have 2 times 60. I'm just going to write that over here. You'll have 2 times 60, and then x times 12. X times 12. 2 times 60 is 120, and x times 12 is 12x. From here, you would isolate x by dividing by 12 on both sides. Then you'll know what x is, or how tall the baby koala is. Number 2. Oh, okay. An octagon has an area. Of 56 square feet. So I know that the area is 56 square feet. And it's going to be dilated by a scale factor of 3. So there's a scale factor of 3. And it wants to know the area of the new octagon. Using my cheat sheet, I know that the new area is just going to be the old area times the scale factor squared. That's just the scale factor times the scale factor. You know the old area is 56 times the scale factor again. Okay. Number 3 says a parallelogram has a perimeter of 28 feet. The figure is dilated by a scale factor of 1/2 to produce a new rectangle. What is the perimeter of the new parallelogram? So we know that the original perimeter is 28, and there's a scale factor of 1/2. So what's the perimeter of the new rectangle? I'm looking for the new perimeter. Using what I know about dilations, and I can look at my cheat sheet to help me. The new perimeter is just the original one times the scale factor. Give me one moment. Okay, I'm back, and there we go. So it's the new perimeter of the rectangle is just going to be the original perimeter, 28, times the scale factor, 1/2. Okay. Number 4 says that a table is 3 centimeters wide, and now after the dilation, the table is 6 centimeters wide. So let's calculate the scale factor used in that dilation. So we know that the original table was 3 centimeters, this tiny table, and the new table is 6 centimeters, and we want to know what was the scale factor. Okay, if we don't know the scale factor, we say, oh no, I have to divide. Where n, the new thing, is the new thing, so 6 is in the numerator, and then the original thing is in the denominator, so 3. Now you just do 6 over 3, or 6 divided by 3. Okay. Alrighty, looking at number 5, we need to find the value of x. Now it's probably a little hard to see on this screen, but this piece here says x. Okay, and what I've noticed is the trapezoid was rotated. It was turned 90 degrees clockwise. So this shorter flat piece is now right here. And the longer flat piece is now right here. Okay, and so then this piece would be the one after I turned it 90 degrees. This is in the same position as x. So the side labeled 9 is in the same position as x. Remember, these could be labeled with letters, and then you might have to set up a proportion using the letters, so pay attention to how you would name the sides. Okay. In this case, though, I just have to find the value of x, so I'm just setting up a proportion. I'm going to assume, because this is a similarity review, that these two shapes are similar. Okay? So I could say that 9 matches with, I could say x, or I could say 18. I could say 9 matches with x, just like I pulled from this trapezoid, so in this fraction I have to pull from this trapezoid, so 18 matches with 4. Now you've got a proportion, and you can cross multiply 4 times 9 and 18 times x, and then you can solve the equation. Okay, and that's the front page. Now I'm moving to the back of that. Okay, this wants to know, what is the scale factor for the given pair of images? Assume the figure on the left is the pre-image. So here's the pre-image, and here's the image. Pre-image, image, okay? So it looks like this is getting smaller. Since this is getting smaller, or there's a reduction, I know I have to multiply by something smaller than 1, which means we couldn't have possibly multiplied by 4 or 2, so automatically I'm going to cross those out. Okay, now I don't know what the scale factor is. Oh no, I don't know what the scale factor is. So I need the new thing over the original thing. The new thing is called the image. The new thing is 12. The original thing is 48. We can type on the online calculator to figure out if our answer should be 1/2 or 1/4. Number 7 wants us to find the length of x. And this time I've got some triangles here. I've got a small triangle that I'm outlining in this bright green color. It's bright green to me. I don't know if it's bright green to you guys on the video. And then I've got a much larger triangle that I'm outlining in orange. Okay. Now they are facing the same direction. So I've got that 40 matches with 16, just like 10 matches with the entire side x. So I could say 40 matches with 16, just like 10 matches with x. Now we cross multiply, solve the equation, and we'll know what x is. Okay. Here's a few. Now we're into some transformation questions. So this is how things change. Number 8 says we've got a figure. We want to know the algebraic representation if it's a translation going 8 right and 4 down. It's a translation. which means I should use add and minus in my rule. So automatically I'm going to cross out D because this is multiplication. Okay. Now this is going 8 units to the right and 4 units down. I'm going to draw and label a graph. This is positive x, positive y, negative x, negative y. If I move to the right, that's changing x with a plus. So this would be x plus 8. And if I move down, that's changing y with a minus, so that would be y minus 4. So the algebraic representation would be that. Number 9 says that we've got we need the algebraic representation for a dilation that is an enlargement. Enlarge means get bigger. And if it's getting bigger, I multiply by bigger than 1. Okay, so what you would do is just look at the scale factors. A has a scale factor of 1/3. You can type that in on the calculator if you don't know already if it's bigger than 1 or not. And if you get something smaller than 1, it obviously couldn't be that answer, right? B says 0.1x, 0.1y. Well, 0.1 is much smaller than 1, and I know I need an enlargement, so I have to multiply by bigger than 1. It can't be B. You guys can type in the remaining scale factors. In letter C, the scale factor is 5/6, and in letter D, the scale factor is 5/2. So you're really just looking for which of these fractions is bigger than 1, because if you're going to multiply by something bigger than 1, you'll get bigger or in larger shape. Okay. Number 10 says that a figure has a perimeter of 40 and an area of 100. What would describe the new perimeter and area after it's dilated by a factor of 1/2? So the original perimeter was 40, and the original area was 100, and the scale factor is 1/2. Remember that perimeter, the new perimeter anyways, is going to be the original one, 40, times the scale factor, 1/2. And the new area is going to be the original area, 100, times the scale factor squared. That's the same thing as the original area times the scale factor again, times 2 scale factors. And then you want the answer choice that would describe those expressions. Moving on to the last few questions. Number 11 wants me to match each coordinate notation to its corresponding transformation from the box. Notice that not all options from the box will be used. Okay. Letter A says I've got xy moving to negative xy. So what I've noticed is there's one sign change, which means letter A is not going to be a dilation, and it's not going to be a translation because those are using numbers, right? So that means this could be a rotation or a reflection. If the letters stay in the same order with only one sign change, it has to be a reflection. So I know this is going to be a reflection. If the letters are in the same order but there's 2 sign changes, then that was a rotation for 180 degrees. Letters are in the same order. I've got one sign change. This is a reflection. So think about if you reflect over one, you change the other sign. So which one did we reflect over if we changed the x's sign? Okay. B says normal x, normal y transforms to y negative x. The first thing I see is that the letters are switched. Now if I notice that the letters are switched, this is probably a rotation, and the only way I know to make a rule for a rotation is by labeling the axis positive x, positive y, negative x, negative y. I need to know how many turns would I use to find y on the right and negative x going up. So if I turn this once, now y is on the right, negative x is on the up. That was once to the right, so that would have been 90 degrees clockwise. Think about how many times you would have had to gone counterclockwise just in case, because we can turn in two directions. If I turn once, negative y is on the right, and x is on the up. If I turn twice, negative x is on the right, y is on the up. If I turn 3 times, y is on the right, negative x is on the up. So 3 turns counterclockwise, or 1 turn clockwise, gave us this rule. Letter C shows us normal xy is transformed to 2.5x, 2.5y. So I'm multiplying here, and multiplying is my keyword to remember a dilation. We're multiplying by 2.5, so the scale factor should be 2.5. Letter D says we have normal xy moving to x plus 3, y minus 5. Pluses and minuses with numbers is my key, for this is sliding, this is a translation. Think about on your labeled axis, if you were going to have x plus 3. X plus is on the right, so you're moving right 3, and then think about where y minus is and what it would mean to have y minus 5 as you add or subtract to y. So you'll just match these transformations that we talked about to the letters M through S. Okay. Now for 12 through 16, we want to, that there is a coordinate plane on the back provided to us if we would like to use it, which is very nice. Wonderful. Okay, so 12 says that we have the following coordinates dilated by a scale factor of 1/3. Dilate means multiply. Dilate means multiply, and we have to multiply by the scale factor 1/3. So on my online calculator, I would just take each of these ordered pairs, so like -3, 12, but I would say times 1/3 by it. And when I type that in, the new ordered pair will be written here. So for point B, you would type in 1/3, the scale factor, times the 0.912. And for point C, you would type in 1/3, the scale factor, times 15/3. Okay. Just because each question here uses the same ordered pair, we're going to work with ordered pair A together, but you guys can be responsible for finding B and C. Okay. When you type in 1/3 times -312 on the Desmos online calculator, that will show you -1, 4 is the image ordered pair. So A prime is now at -1, 4. 13 says the image from above is going to be rotated 90 degrees clockwise to obtain a new image. Record the ordered pairs of the image, of the rotated image. Okay, so A prime is going to be rotated 90 degrees clockwise. That means we have A prime from the previous question, -1, 4. So you're using the new ordered pair from the last question as the starting point in the new question. So you'll use the ordered pair 9, 12 as B prime, and you'll rotate that 90 degrees clockwise to find the new B, or B double prime. And then for C prime, you'll use, sorry, you won't use 9, 12. You'll use 9, 12 times 1/3, right? And for C prime, you'll use 1/3 times 15, 8. And then you can rotate that. So you're using the previous ordered pairs as the pre-image for the next question. The previous ordered pair, the previous image we had was -1, 4. We're going to use -1, 4 for our pre-image in number 13. And we're supposed to rotate -1, 4, 90 degrees clockwise. So I'm going to flip to the back where that coordinate plane is. Now we said A prime was at -1, 4. This is A prime, and I'm supposed to rotate it 90 degrees clockwise now. So I'm going to take my paper, turn it 1 time to the right, and now A, after the turn, so after its change, it's going 4 right, 1 up. 4 right, 1 up would be positive 4, positive 1. So the new A is at positive 4, positive 1. Okay, so with 14, I'm going to take that ordered pair, 4, 1, as the pre-image for A. And now I need to translate it using x minus 3, y plus 3. X minus 3 means I'm going to go left 3 times, and y plus 3 means I'm going to go up 3 times. There's 2 ways you can do this, and I'm going to show you the way on the graph first, because that's what most of us prefer. So first things first, I should plot 4, 1. On the other graph, I'll plot 4, 1. So I don't get confused, you can cross this out, you can erase it, you can label this one A double prime so it has different notation, whatever you need to do to remember that we're using this point right now. Okay. Now that rule was to go left 3 times and up 3 times. So from that point, I start at that point and I count left 3 times, 1, 2, 3, and then up 3 times, 1, 2, 3. And that's where the new ordered pair is. So now the new ordered pair is at 1, 4, 1, 4. So now I have A at 1, 4. Again, you would just use the new thing, the image for B and C from 13 as the pre-image for B and C in 14. Okay, so that means I'm using 1, 4 as the pre-image. 1, 4 as the pre-image for A, and the next question, 15. Okay, so I need to reflect the translated figure needs to be reflected over the y-axis. It's asking me to flip over the y-axis. Now before I go on, let's go back up to 14. I did forget this. In number 14, we had 4, 1, and that was going left 3, up 3. This said x minus 3, so x was 4, minus 3, y was 1, plus 3. I just used the rule, but filling in x and y with the points x and y. Okay, so 4 minus 3 is 1, and 1 plus 3 is 4. So the ordered pair should have been 1, 4. I know some of you prefer using this because it's more adding and subtracting, and some of you prefer using the graph because it's more visual. So remember, you can use both ways. That is fine. Okay. Again here, so we're going to reflect over the y-axis. There is a rule for that, and if you know the rule and prefer the rule, you can use it. Remember, if you flip over y, x changes sign. Flip over one, the other changes sign. Most of us prefer the visual way, so I will plot 1, 4, and then we'll reflect over the y-axis. 1, 4 has already been plotted. We need to flip over the y-axis. That's the up and down number. 1, 4 is 1 away from the y-axis, so count again 1 away, and now we're here at -1, 1, 2, 3, 4 up, at -1, 4. So the newest A is going to be at -1, 4. 16 wants you to just plot the last ordered pairs that you have. So on the graph, you're going -1 up 4, and we're going to call that A with 4 apostrophes there. Okay? So you're using the same ordered pairs the entire time. You use the new ordered pair from whatever transformation you're using as the pre-image in the next question. You're transforming that somehow, using that as the pre-image in the next transformation, moving it somehow, that's the image. Use that image as the pre-image in the next question, and then your final ordered pairs are what we have to plot on the graph. Okay. If you can get through this review, you should be all set for tomorrow's test, because that would mean you're an expert at transformations. If you have any questions, feel free to contact your teacher via Schoology. All of our emails are on the district website, or you know where to find us at school, before or after school, during class. Ask us your questions. We'll be happy to answer.